Okay, good morning, everyone. My name is
Kevin?
Kevin Zhao, Senior Global Technical Specialist in Phenomenus. Today, my topic is HPLC troubleshooting, column care, and understanding where blood pressure comes from. The objective and topics for this talk will be the following six: pressure problems, leaking problems, variable retention times, uh, quantitation and data qualities, baseline, and take care of your columns. So first is the pressure problem. According to HPLC blood pressure problem, we can first identify the following most common issue that can be encountered, which is pressure too high, pressure too low, unstable pressure, and low pressure at all. On the other hand, we highly recommend to constantly monitoring the blood pressure all the time. It is really critical because the system pressure is one of the most important performance diagnostics at your differential and secondary, and pressure is also indicator of the system performance. This is the formula of HPLC pressure. According to this formula, we can understand the pressure is a function of viscosity, which is related to the column temperature, mobile phase composition, and linear velocity, which is related to the flowway column inner diameter, column length, and lastly, the column media particle size. Please also keep in mind the LC system itself is also a contributor of the pressures. For high pressure, we are going to ask, is the high pressure due to my system or due to my LC column? First, we can try to use union instead of the column to check our pressure. If the pressure is still high, compare the similar system that are not expecting problem, you know the problem is with your system. Secondly, tubing will be another major part of the causing of the high pressure issue. Check for location of the blockage from detector to pump. Disconnect one fitting at the time. Replace filter or tubings. Flush and backpressure detector, column, or injector to try to find out where is the blood pressure. Typical cause the high system pressure, there's three different factors. The first one, sample. Particle and matrix contamination can clog the liner or injected needle. And we can try to replace the PEEK tubing, perform check out on the auto sampler, filter sample in the future. So the second factor might be the mobile phase. Salt can precipitate out, or bacteria can grow in aqueous buffer. So for this reason, we can try to flush system with water to dissolve the salt, wash or sonicate intake filter, make new and fresh buffer more frequently. Consider adding something like sodium iodide to buffer to reduce microbial growth, bacterial growth. Buffer solution will grow bacteria really fast. Lastly, LC system. Valves, O-rings degraded over the time. So replace the valve and increase the preventive maintain frequently as lead. Check buffer and solution and check the wear on the prison wall and seal the degree more quickly. If the pressure problem is isolated to the LC column, then you first need to determine whether the increase in the pressure is normal or unexpected. LC column is just an expensive filter that will capture everything in the sample and mobile phase that is not completely solved. So even with normal routine use, the pressure on the column will usually increase over time. So we need to really think about the particular build-up or the contamination compressed of the pest-sorbing bed with pressures. For checking this column pressure issue, it will be better to replace another new same column if possible to verify if the column issues. As I mentioned at the beginning with the formula of the column pressure, mobile phase viscosity will be one of the major functions of the cause the pressure problem. This comparison diagram show the viscosity of the water organic solvent mixture is a function of the percent compression. Isocratic method should have a stable pressure. As you want a gradient, the pressure will change during the run as mobile phases change. Acetonitrile is a favorite mobile phase of LC because acetonitrile have greater elution strength, lower UV absorbance, lower viscosity, and also lower pressures. Other than high pressure, we sometimes will face low pressure as well during the LC method. If we see low pressure, then check the leaking in the system, pump problem. Lastly, the column has bubble or air inside, also will cause the low pressure. So please make sure that do not run out the mobile phase when column is still connected to the running LC system. Last but not least, if we also see low pressure at all, it might be some major pump problem, such as low power support and low pressure or pressure shutdown, motor and piston broken, replace check valves and piston seal, and the gas mobile phase bubble. Pressure transduction, pressure valve failure, and low mobile phase support and major leaking in the system. That's all factor to cause low pressure at all. However, if we see the unstable pressure problem, it might be caused by pump problem and particularly precipitate buffer, and also with gradient illusion, unstable pressure should be normal. And also check the need of the system. So second major problem is leaking problem. Tubing and feeding can also cause the leaking. Feeding is the major cause by the leaking issues. So sometimes we using a different brand feeding connect to, for example, phenomenous column. So different feeding sizes also will broken the end feeding of the column and causing the leaking. And pressure, if the pressure too high, the leaking might come out. So in this slide, I'm showing the feeding pressure routing relate to different tubing and feeding. The high pressure stainless steel feeding and stainless steel tubing can support highest pressure. In here, I also want to mention that our phenomenal security link feeding and tubing set is highly recommended for both HPLC and UHPLC customer that can provide a stable pressure for you daily use. So here is the pump leak. So if we find out the leaking is causing by the pump, so that's the major area it might causing the leaking. So here is the piston seal, and this part is the scotch in the piston, and also the check valves, the pumpation valves, post diaper, pressure transducer, pumpkin valves, and also mixture is the major part to causing the leaking in the system. The second major factor causing the leaking is the injector leak. So injector leak might leading in these following parts. So rotor seal, looser stator, injection plug seal. That's the syringe needles, injector loop, and waste line as well. So those parts is also major parts to leaking the injector leaking issues. Column leak. If we facing column leaking, so here is the major area to causing those column leak. First is losing the feeding. Second is losing the column end feeding. And the last one is losing the security guard holder. So let me take a quick break here, and I want to ask all of you guys, do you or someone in your lab struggle with the column performance problem? Okay, so if you answer the question, I will keep continue. So variable retention time problem. Other than pressure issue, the shift of retention time issue will be another most common HPLC troubleshooting question. Difference between hardware and chromatograph problem. Measure T0, which is the depth volume, is considered and variable. We normally use USL to determine the depth volume. If T0 is variable, system problem, flow rate unstable. If T0 is constant, chromatograph problem. If T0 is variable, we need to measure the pump flow, troubleshoot the pump problem. So we can replace the check valves and also piston seal. And second is degas the mobile phase, try to remove all the bubble from the mobile phase, and replace the inner filter. Alternative diagnosing the approach compare the reproducibility of the peak height and peak area measurement. If the peak height is reproducible and peak area is low, then the problem lies with the pumping system. On the other hand, if the peak area is reproduced and peak height is low, then it is a chromatograph problem, such as different mobile phase composition. If the T0 is constant, then solvent preparation might be wrong or variable. If the retention time is increased, which is shift to the peak shift to right, solvent strength is lower. But if the retention time has decreased, solvent strength is higher. Test mixture and proportion values of the inconsistent online mixing. Check gradient and mix mobile phase for isocratic run. Avoid the lower boiling composition if the mobile phase is pre-mixed. With the ionable analyze pH has to be controlled with a buffer. pH should be within the buffer range. Keep pH 2 unit always from the pKa of the analyze. To get maximum retention and good peak shape, acid one under acidic condition, so basic one under basic condition. pKa of some functional group I'm showing in this table. For example, the amino group have much higher pKa than carboxylic acid group. According to buffer selection, mobile phase pH fit to buffer range. Ideal of concentration of the salt that we can use on LC will be 10 to 20 millimolar for UV, 5 millimolar for mass spec. So we also need to keep in mind, if we are using mass spec detector, we need to choose a mass spec compatible buffer to use it. Check column equilibration time. So normally we do column condition in 10 column volume. To strong injection solvent reduce retention time, inject in mobile phase or 100% resolvent. Fluctuating the column temperature. So Consider we keep column temperature stable, so we recommend to using column oven. Higher temperature leading the decreasing of the retention time. Lower temperature leading the increasing of the retention time. Column age. So contamination build up will also causing the retention time shift. So we need to clean your column regularly. Rules of the stational phase. Stay within the pH limit of the column and use more stable one. Warm column use. Different phase, carbon node, or surface area will also causing the retention time shift. More carbon node and more surface area will lead the longer retention time. I'm showing the example here. So we can see we are using two different type of Luna column. The more carbon node, which is Luna C18 regular C18 first generation column, has 19% of carbon node, compare the second generation of Luna C18, which is 17.5% of carbon node. So we can see higher carbon node of the column leading longer retention. So the loading capacity, mass overloading of the column also lead the shorter retention time here. So here is another two question. I want to stop a little bit. So do you want to be contacted for help with your method development or application development? So please answer it and let us know. Okay, let's get continue. Quantitation and data quality problem. So the quantitation and data quality, we will focusing on four different parts. One is the sensitivity, recovery, linearity, and resolution. In sensitivity problem, we normally use a term called LOD or LOQ. Enough sample injection, increase amount. So if we see our problem is low sample injection, so we can consider increase injection amount, check injector or syringe, and low efficiency of the column. So then we can consider exchange column or use UHPLC. If we facing our result is not meeting the LOQ or LOD, then the last thing might be the detection problem. So check setting like sample connection rate and maybe wrong integration parameter, read detector lamp, dirty or too big detector cell, use more sensitivity detector, something like mass spec. It might increase your LOQ and LOD as well. In this slide, we use example to show that the higher efficiency column can provide higher sensitivity in the same method with same amount of sample injection. So compared to regular fully poured column in the left, we are using core shell column in the same column dimension, similar particle size. We will see much higher efficiency on the result. So it caused the higher sensitivity of the column. Recovery rate problem is a compound related issue. So some compound lose during the sample preparation, decomposition of the sample components, priming issue. Sometimes the column need to be conditioned during first and second injection. Um, Absorption is of the proteins. So if we're working on some protein sample, the column usually absorb some of the protein, and basic compound should needing the secondary interaction with the silica surface. So for this case, we use inner phase like kinetics XPC18, PSC18, or EVOC18 to low down the secondary interaction. Acid and colliding compounds. So we typically use type B silica, which is more pure of the silica to lower the chelation of the compound and the silica. So here is showing what I just mentioned, the priming effect. So for GFC column, which is the SEC method, so we can see between the first injection, second injection, and third injection, the protein sample might be absorbed by the column. So we normally use at least one or two, sometimes three injection to prime our column to make the column stabilize with your protein compounds. Most of the old silica particles, such as type A silica, has metal impurity. So those metal impurity are causing the chelation. Analyte can interact with the metal impurity in the basic silica. This follow comparison is showing the difference between type A silica column and type B silica column in the acid compound analysis. So here is the comparison, the result showing since type A silica has much more metal impurity than type B silica, the bottom chromatogram missing one major peak, which is the metal chelation on the type A silica column, leading the lower recovery. Linearity is the coelution between sample concentration and the signal. So mass loading, detection, and integration related. Here are some common linearity problems that we can normally see on our LC system. So first one is log enough sample injection and change in the peak shape leading wrong integration. Peak height is used for quantitative use peak area. Column and detector overload, so we need to dilute the sample. Nonlinear calibration block. So at this case, we need to create more data point or use nonlinear regulations. Standard are good, but sample is not good on the result. So it might caused by the matrix effect. In this case, we can change method or improve sample preparation method. So compact sample matrix will be one of the major factors to cause the linear issue. So at this case, we might consider using SPE step to clean up, to reduce the matrix effect. Ion suppression will be another major linear issue when we're using mass spec detector. So again, so if we facing some ion suppression, solid phase cleanup SPE is really helpful. So last but not least, the resolution is another problem we want to facing. So low resolution from the first injection. So why we cause that is effect too low. If that increase the column length or decrease the particle size, and throw away ideal factor to change, but we need to consider we are using best flow rate on your method. So we can just slightly change the flow rate and also consider some detector setting as well. Use the right column selectivity. If the stational phase is wrong, the resolution might not be good as you want. Keep the K factor between 2 and 10. So last one should be the baseline problem. So the last part of the troubleshooting idea is the I will cover the baseline problem. So how we check the baseline problem. So stop pump. If the noise stop when due to the solvent flow, pump or chromogram. If the problem still there, we need to check the detector lamp, electronic shielding, and temperature as well. So GIF baseline. If we see GIF baseline, mobile phase contamination, that's the major issue. So negative GIF, mobile phase A, have resolvent. Positive GIF, maybe mobile phase B, strong solvent. Column temperature, slow column equilibration, strongly retain materials, contamination in the detector, slow stabilization of the detector as well. Regular baseline noise. So if we see the baseline noise, that's two major regular baseline noise we normally see. One is the cycle baseline change, and the other one is the white noise. So the last one is there's three irregular baseline noise. So it's split baseline. So if we see the split, which is the use of electronic shielding or use another circuit, and if we see the offset shift, it means bubble in the tubing or in the column. bubble need to be degassed. Irregular peak. If we see some irregular peak showing on the result, so means impurity in the system or column, impurity in the mobile phase that um, enrich on the column as well. So I before I end up the my talk, I want to use 2 to 3 slides to show you how to take care of your column as well. So taking care of your column, clean your column to prevent the column shorter lifetime. So due to daily use, at the end of the day, daily use of your column, please make sure you clean your column. Goal is rinsing out, wash out all the salt and buffer using neutral pH. And also from we use gradient method from low to high organic gradient method to wash out all the impurity and carry over compounds stay in your column. So for column long-term storage, we recommend you store your column with the shipping solvent for long-term storage. So if we are planning don't use your column for at least 2 to 3 weeks, then we might consider using the shipping solvent to store your column for long term. And column regeneration. If we find out the column has decreasing of the column efficiency, the column has the carryover happening, pressure is going up, then we might consider using column regeneration method. So each column reverse phase, they have the reverse phase column regeneration method. And I'm showing here is the reverse phase column regeneration method. And if we using normal phase or helix column, we have another helix column specific column regeneration method as well. So if we want to look at what kind of column shipping solvent of phenomenal column, we can always check out our phenomenal catalog. At the back of the catalog, you will find this table. The table on the left is the column shipping solvent of phenomenal column. And in the middle is the column regeneration method I'm showing for different type of phenomenal column as well.